Alright, so we want to find f prime of a for the following function. F of x is equal to 1 plus 2x over 1 plus x. And to do this, I'm going to be using Archimedes' quotient. So once again, Archimedes' quotient, f prime of x, f prime of a is equal to limit as x approaches a, f of x minus f of a over x minus a. Okay, and we can use this to basically find the slope of the tangent, also known as the instantaneous rate of change, at a point where x is equal to a. Okay, so we're just going to purely use algebra to model this scenario. So in this case, if we plug this in, we know that x is going to be equal to a. F of x in this case is basically equal to 1 plus 2x over 1 plus x minus f of a. So if I plug in f of a, you get 1 plus 2a over 1 plus a. And this is over 1 plus x. Minus, this is over x minus a. Okay, you can notice here that as x approaches a, then the denominator becomes 0 and the whole function becomes undefined. So we need a way to cancel out the x minus a. So what I'm going to do is I'm going to simplify the numerator first. So I'm going to simplify all of this, right? Let's use a different color just to kind of show that. So I'm going to simplify the numerator. Okay, and the way I'm going to do this, the lowest common denominator now is 1 plus x times 1 plus a. Okay, so then I get 1 plus 2x times 1 plus a minus 1 plus 2a times 1 plus x. Okay, so you get 1 plus a plus 2x plus 2ax minus 1 plus x plus 2a plus 2ax. Okay, and then if I expand this out, you get 1 plus a plus 2x plus 2ax minus 1 minus x minus 2a minus 2ax. Okay, and let's see what we can cancel out. So we can see that we can cancel the positive 2ax and negative 2ax. The doesn't seem like you have a 1 here, the 1 and the negative 1, right? 2x minus x is x, and a minus 2a is minus a. Okay, so you can see that here. So you're left with x minus a, right? And that's for the numerator, and the denominator here is basically going to be 1 plus x over 1 plus a. Okay, so now what we're going to do here is we're going to plug this back into the limit, and if we plug this back into the limit, I'm just going to change the colors again. We're basically going to get something like this. F prime of a is equal to limit as x approaches a, x minus a over 1 plus x 1 plus a over x minus a. Okay, now we still have this x minus a on the denominator. We need to get rid of that. So you can actually split this guy into limit as, x approaches a, x minus a over 1 plus x 1 plus a times 1 over x minus a, right? Because you're dividing it, you can multiply its reciprocal, right? So in this case, you can see that the two factors cancel out, and now the restriction is gone. Okay, so now you can notice that if you do simplify this together and you combine it together, you get 1 over 1 plus x 1 plus a, limit as x approaches a. Now that the restriction is gone, you can let x equal a freely, and in that case what you're going to get here is 1 over 1 plus a times 1 plus a, which is 1 over 1 plus a squared. Good. So that is your slope of the tangent when x approaches a, or basically f prime of a.